So the uranium fuel cycle starts with effectively dirt and then turns that into spent fuel and hopefully recycling. Now, let me walk you through this. This is the nuclear fuel cycle. You find some dirt that's got more uranium in it than normal. Typical dirt has about 3 parts per million uranium. You go and you mine that, and then you mill it. You crush it really, really fine, and then you leach it. You expose it to acid to get out the U3O8. It's a very common process in metal mining. Once you've got that, the U3O8, the yellow cake, you're then going to convert that into uranium hexafluoride. That's another chemical process. Once you've done that, you can send that to a gaseous diffusion plant or to a centrifuge where you enrich the uranium hexafluoride in the isotope uranium-235. So the natural amount of uranium-235 in regular uranium is about 0.7%. You enrich that by taking that small amount of uranium-235 and you make it bigger. But that gives you waste products. It's called depleted uranium, which has a lot less of the uranium-235, maybe about 0.2%. So that becomes a waste product, which could actually be reused. We'll get back to that here in a second. So then after you've got this enriched uranium hexafluoride, you then do another chemical process to convert that into uranium dioxide, UO2. That then gets pressed into pellets and sintered, which then goes into the fuel rods to go critical, make heat, and make electricity. After that, you have the spent fuel. If you just take the spent fuel and send that to a geological repository, you've only used about 95% of the total energy that was there. You just spent all of that energy and resources in the mining and the milling and the enrichment and the conversion, the chemical conversions. All that energy, you only get 5% of the total. If we recycled it, we could keep getting all of that energy out iteratively. Furthermore, if in that recycling process we were to fold in the excess depleted uranium, there's a lot more of that than the enriched uranium, then we could substantially increase the total amount of energy that we're getting from this effort of mining and milling and conversion and enrichment and so forth. That does require that we recycle, but not that we only recycle the spent fuel, but that we fold in mixed oxide fuels with the depleted uranium. It becomes a lot easier if you have breeder reactors or something like that, but that's not necessarily needed, at least not in all cases. And so then the nuclear waste has to go to a geological repository. If you're only doing the ones through, then you've got the plutoniums and the actinides, which has 10,000 year half-lives. But if you do this full recycle sustainably, 30-year half-lives become possible. So it's a big difference if you do a full recycle, especially with depleted uranium. That would be the way I would say we should